All right, everyone. So today we're going to do some notes on fronts. And what I'm going to be doing is this is how your notes are going to look. I shared with you this, just this little chart. So instead of filling in a long drawn out note sheet, what we're going to do is we're just going to fill out some things that you need to remember. Just sort of have them all listed in sort of a bulleted fashion. So let's start with cold front. So we're going to start with cold front. Now, what we're going to do is we're actually going to talk about the symbol first, and then we're going to draw it, and then we're going to talk about what's happening in each of these fronts. So a cold front actually has the symbol with little triangles on here. Some people like to remember that they're little icicles on there. All right. And the symbol actually gives you the direction that the front is moving. So that front right there with those little pointy triangles, are moving in the direction of the triangles. And what I'm actually going to do is we're going to talk a little bit about this front by actually showing you how the front is setting up, and then we'll fill in those boxes. So the way that I like to talk to you about this is by giving you sort of a ground view of this front. So this is the ground, this is the air right here. Okay, so ground and air, just to orient yourself. So we have a sun, if we want to talk about our sun, that's how that's fitting in here. All right. And when we have a front occurring, we have air masses colliding. We have air masses colliding at a front. That's exactly what a front is. Think of a front when we're thinking of war as two sides of an army colliding. At a front, when we're talking about weather, we're talking about two air masses colliding. And the last time that I talked to you, we talked about air masses forming over water being moist and over the tropical regions being warm, and air masses that form over land being dry, and over polar regions being cold. So in this case, in a cold front, we have a cold air mass colliding with a warm air mass. So our warm air mass is over here on this right side, and our cold air mass is over here on the left side. Now, if we think about these air masses, we know that cold air is contracted, and the molecules of cold air are more close together and they're more dense, and our warm air tends to be more spread out. And that's pretty significant here because this cold air is sort of hanging out down near the ground, and this warm air tends to be more expanded and a little bit lifted off the ground. And if this warm air moves this way and this cold air moves this way at a cold front, guess what air mass wins? You got it. The cold air mass wins. So at a cold front, the cold air mass wins. So that means that this air mass on the left-hand side is stronger than the air mass on the right side. So what happens is we get a really steep front right here. The cold air mass actually makes this warm air get forced up. And it gets forced up. Look at how steep the side of this front is. It gets forced up really quickly. And think about what happens when this warm air gets forced up really quickly. It actually cools very quickly. And you can see the cloud that I drew. I drew an anvil-shaped cloud, and this specific cloud is called a cumulonimbus cloud. It's an anvil-shaped cloud. It's really, really high. So it's got low elevation and it's got very high elevation. So it's considered a really long cloud. And this cloud forms when the warm air is forced up and cooled quickly. That's the key word here. It's cooled quickly. And when this air is cooled quickly, it actually forms all of these cloud droplets, and we get some really huge up and down drafts in this cloud. This cloud has the ability to give us pretty heavy rain showers, and if I can draw lightning, thunder, but covering a small area at the front. So again, just to go through this one last time before we start writing this down, a cold front would be when a cold air mass collides with a warm air mass. This cold air mass is the winner. It shoves this warm air up where the warm air is cooled quickly, very quickly, sort of violently. And it forms a cumulonimbus, forms some heavy rain, thunder, lightning, possible tornadoes, possible hail at these storms. All right. And again, we got our direction of our front motion based on the front here. So this front will actually advance this way towards the right because this cold air mass is winning. This front will move. So this thunderstorm will move this direction. So a city over a person living at A probably just had a thunderstorm. B is having a thunderstorm now, and C may have the thunderstorm in the future as that cold front advances. So hopefully that makes sense. Let's go ahead and see if we can fill in this chart. So what two air masses are colliding? What did we say? We said it was cold air, a cold air mass, and a warm air mass were colliding. So a cold air mass collides with a warm air mass. Which air mass won? Well, it's a cold front, so the cold air won. Is this happening at a high pressure or a low pressure? Well, let's think about this. If cold air collides with warm air, is that more characteristic of a high pressure where the air is moving away? Or is this a characteristic of a low pressure where the air is moving in? You got it. It's the low pressure. So here's the thing. I can go ahead and fill this in for all of these. Because if air is colliding, then I know it's happening at a low pressure. So let's go ahead and do that for emphasis. All of these fronts, because air is colliding, would happen at a low pressure. So that's pretty significant. Low pressure would be our bad weather. And I've been saying this up until now. Anytime we have air masses colliding, anytime we have weather, like bad weather, thunderstorms, tornadoes, rain for days, we have air masses that are colliding. We have air that's coming together. When air moves away, as in a high pressure center, this is nice weather. This is our fair, sunny weather. This is the weather that we don't have to worry about. We'll go to Six Flags, we'll go to Water Slide World or Zoom Flume. Those are the good days. All right, so how fast does this front move? You probably know this just by knowing a little bit about characteristics of thunderstorms, that the front moves very fast. Because if you have a thunderstorm that moves in, sometimes you can wait it out. You can go inside, you can hide away somewhere and then go back out and play after that thunderstorm has moved through. So they do move really fast. All right, is the air moist or dry at the front? What do you think? Moist or dry? Well, if it's raining, what do you think? It's probably going to be pretty moist. It's probably going to be pretty moist. What type of clouds are present? Did you catch it? Cumulonimbus clouds are present at the front. The weather that accompanies thunderstorms, heavy rain, possible hail, did this front cover a small area or a large area? All right, this covers the area right at the front, right at that location where those two air masses are colliding. So it covers a small area. After the front passes, this is when it gets a little tricky. How would the air temperature, so how would the temperature, the humidity, and the pressure change? Well, let's think about this. If it's happening at a low pressure, what's going to happen after this front passes? The pressure is probably going to increase a little bit. All right, so the pressure is going to get higher because this occurred at a low pressure center. The humidity probably will decrease because if it's not raining, the humidity should go down. We're also replacing it with cold air, which tends to be colder. All right, so we get colder air. The humidity would be less. All right, the less relative humidity, and the pressure would probably increase a little bit because those molecules of air would be closer together, they would be colder, and they would be holding less moisture. After this front, the wind speeds are usually pretty high at the front and then after the front. So you probably have noticed that after a thunderstorm, sometimes that wind speed gets going pretty good. All right, so hopefully that makes sense. Let's see if we can contrast this with a warm front, because I think that's when you start seeing all these patterns set up. All right, so a warm front. Let's just shift over here to the warm front. The warm front is slightly different symbol. These symbols, by the way, are all in your reference tables on that same page where there's a thermometer and a pressure conversion. Right, so the warm front has little circles. Some people like to think of it as rising suns, although they're green here in this case. But the warm front also shows the direction the front is moving, but they're little half circles. So that's how the warm front symbol looks. A lot of this is going to be the same. I'm going to shift over to this side of my paper and draw for you a warm front. Now, as far as your diagrams go, I would expect for you to be able to draw a cold front. I would expect for you to be able to draw a warm front. All right, so make sure you know how these fronts are, how they're illustrated. Make sure you know how to identify them. All right, so we're going to go through the same pattern where we're going to have a warm front symbol moving this direction. And I also want to orient you. This is our ground right here, and this is our air right there. Okay, so the warm front. Now, when we do a warm front, we're going to think about what's colliding. Okay, so warm air is over here. Cold air now is going to be over here. Now remember, cold air is really, well, it's cold, but it's also contracted a little bit more dense. So remember, this cold air is sort of hanging out lower to the ground, whereas the warm air tends to be a little more spread out and a little bit more aloft off the ground. And so what we get is sort of a different front pattern. Remember how steep this front pattern was, where we had where these two air masses collided, we had a really steep boundary. In this case, we don't have that steep boundary. We have a sloped boundary. It's slightly different. And we have our warm air mass coming this way, and our cold air mass is coming this way, because that's what a front is, right? When two air masses collide. So the warm air mass collides with this cold air mass, and they're colliding together. But the key is, this is a warm front, which means the warm air mass is winning in this case. The warm air mass is beating the cold air mass. And it actually shifts right over that cold air, and it forces this cold air to scooch backwards. All right, think of like holding a seed. If you ever carved a pumpkin, you know when you pull the pumpkin seeds out of the pumpkin and you can sort of squeeze them between your fingers and they are slippery and they just squeeze right out. That's what I want you to envision when you envision this cold air sort of sliding backwards. So as this warm front advances, the cold air is shoved backwards. The warm air sort of pushes on the top to scooch this cold air back. And what actually happens is we get a large layer of stratus clouds right along this front. All right. So the clouds are called stratus clouds. They're a lower cloud. Take a look at what's going to happen at this front. Now, what's significant about this? Well, before when we had our cold front, remember our precipitation was right at or slightly behind the front? Look at where the precipitation is now. The rain is actually going to be in front of this front line. All right, so here's where these two air masses are colliding essentially, and the rain is going to be right in front of it. So this is going to be rain from low stratus clouds. Why did those clouds form there? Well, this warm air cooled. So this warm air that is shoving this cold air back, this warm air is going to cool. And guess what? It's going to cool to the dew point. You already knew that, though. You knew how clouds form. So that warm air is going to cool to the dew point, and that's what's going to form these clouds here right along this front line. So that's considered a warm front. Let's see if we can fill in some of our data for this one. We know that it happens at a low pressure center. And you already know a lot of this, right? You've probably already filled it in. So this time we still have cold air and we still have warm air, a warm air mass. So we still have warm air mass and we still have a cold air mass colliding. That's the same at a warm front. The key is that the warm air is winning in this one. And that's what makes it a warm front, right? Warm front would mean the warm air is winning. This does happen at a low pressure center. How fast does this front move? This actually moves at a slower speed. This would be like a day of rain. Okay, so this would be several hours at a cold front. This would be probably a day or two. Is the air moist or dry at the front? It's still moist because it's raining. The stratus cloud is the cloud that's the key cloud here. And the rain would be, the weather would be rain. Does it cover a larger area or a smaller area? I hope you caught on to this from my picture. It covers a larger area. All right, so it wouldn't be a small area like here. It would be like all of the Albany area or all of New York State would be receiving rain. After the front passes, well, pressure should increase because usually the weather clears up after it passes. The temperature, now here's the thing. If the warm air mass wins, then that means warm air will replace the air mass. That warm air will replace the cold air mass. So the temperature should increase a little bit here because the warm air won and it's moving into that area. And then the humidity, hopefully the humidity will decrease a little bit because it won't be raining at that front. After the front passes, there's usually a moderate wind, and when the front is here, there's a fairly slow to moderate wind speed on during that front. Not a lot of wind, not like a thunderstorm where the wind really picks up. This one's just a slow to moderate wind while that front is over top. All right, the stationary front. This one, I'm going to just start here because I'm not going to really draw too much of it. What I want you to know is that a cold air is colliding with warm air. You're probably sort of getting annoyed because this is the same thing, right? Cold air is colliding with warm air. But the key for this one is that it is stationary, meaning it's not moving anywhere, which means neither warm nor cold is winning. They're like stalled out. If we were in class, I would tell you a story about my boyfriend at the time and my sister's boyfriend having an arm wrestle. And they had an arm wrestle, and now there's a lot on the line because they were trying to impress their girls. And my boyfriend and my sister's boyfriend were just about equally matched in strength. And we were waiting to have dinner, and they were still locked up in this arm wrestle. Neither of them were winning. They were literally sweating and red-faced, and neither of them were winning. They were they were like locked in. Nobody wanted to take the loss. So that's what I always think of when I think of stationary front. They were pretty equally matched in motivation, and they were equally matched in strength, and their arms were like locked in that arm wrestle for a long time until we forced them to let go at the same time. So the way that we draw this stationary front is we have the warm and the cold front are both on the same line, but they're on opposite sides. So I don't know if you can see this, but the warm front and the cold front symbol are both on the same line, but the warm front is on one side of the line and the cold front is on the other. And it's showing you that that they're really, neither of them is winning. So there's really no arrow. There's no arrow showing overall movement of this front. So how does it move? It doesn't. It doesn't move. This is when we could get, 6 to 7 days of the same weather. And usually it's rain. So you get stratus clouds, and usually you get rain for days. This would be, 5, 6, 7 days of rain. Covers a moderate area when these two air masses stall out. And here's the thing. The variable, it's variable. And because we don't know which one is ultimately going to win. Eventually, there will be some factor that causes the cold air mass or the warm air mass to somehow give up or end, because you can't have rain forever, right? But it would be after this long period of time and this front not moving, there would be some movement. So this would be variable depending on whether or not the cold air replaced. That would make this temperature decrease and the pressure increase, or the weather or the warm front or the warm air replaced it, would give it different results. Okay, it would give it a warmer temperature. And the interesting thing about this one is that at that stationary front, there would really be no wind, right? Because there would be no movement of air, because the warm air is advancing as with the same strength as the cold air mass, and so they're totally stalling out when they hit each other. So that's a stationary front. The last one I want to talk to you a little bit about is the occluded front. Now, the occluded front is probably the most complicated front, and I'm actually going to drop down to the bottom, or down here. I want you to know what type of weather accompanies this one. So it's actually the thunderstorms, and these are the severe thunderstorms. We could possibly get a tornado here. We could get a hurricane here. So this would be the extreme weather. This would be the extreme weather. So the type of weather that accompanies is not rain or thunderstorm or hail. This is like extreme weather, has the potential. Your phone would probably give you a warning when this occluded front is setting up over your area, because it is the scary weather. These are the potential for trees falling, power lines being brought down, possible tornadoes. So what is happening to cause this severe weather? What do you think is happening? It's pretty neat, actually. Remember how in all of these prior ones we had cold air and warm air colliding? It's actually different for an occluded front. In this case, it's actually a cold front that's colliding with a warm front. So for this one, a warm front, remember, was 2 air masses, and a cold front was 2 air masses. So the key for this one is that there's actually 4 air masses colliding. And that's why there's really extreme weather at this occluded front. It's because there's so much going on. We have a cold front probably overtaking a warm front, and so I'll talk to you a little bit about what happens on in the weather. All right, so the way we talk about the occluded front, it's sort of cool. With the occluded front, I don't really want you to know a ton of detail. But what happens is we've got a cold front right here. And this is our ground. And we've got our warm front right here. So this is our warm front. And this is our cold front. And the thing that makes this one significant is that the air mass is actually lifted, but the significance is that it's actually held up there. So this warm air is actually shoved up, and then it's held up here. It's forced up here. And so where we have in the cold front, we had that cycling in our air. In this one, we have huge clouds that form, but they're being forced up there and then held there, which holds that warm air aloft and forces the cooling and continued cooling. And so we have a lot of different clouds that form. We have cumulonimbus, we have the nimbostratus, we have an altostratus all along this front. So we'd have a whole bunch of different clouds that would be forming all along this wedge of air that's being held up. And that's why it's so extreme. It's also very unpredictable, because we don't know what's going to happen when this air is forced up and held up there. So again, we have cold air here. We have cold air here, and our warm air is up here. And when our warm air is up here, it's also cooled. So warm air is forced up, held there, and cooled. And that's going to give us pretty extreme weather. All right, heavy showers here, possible thunderstorms. This would be where a possible tornado could result. Definite thunderstorms, definite lightning, hail, all of that would happen right at that front. All right, so let's see if we can fill this in. Oh, and I never did draw the occluded front symbol. Let me go ahead and extend my paper down a little bit. So the occluded front, we'll draw it on the other side on our other paper also. So the occluded front is the same symbols again, but they're alternating. So what I have is I have the cold front symbols, the cold front triangles, alternating with the warm front circles. And that still has a direction. So the occluded front, let's see if I can draw this nicely. So a circle, a circle, a circle. I'm actually going to alternate my colors a little bit so that you can see with a triangle, a triangle, a triangle. All right, so it's circle, triangle, circle, triangle, circle, triangle gives you that front line. And notice the difference between stationary front, those circle and triangle were on the opposite sides of the line, whereas these are both on the same side of the line, indicating the movement of that front. All right, so let's go ahead and fill this in. Now I'm going to fill it in as if the cold front wins, because guess what? The cold front is fast and strong, so usually the cold front wins. So I'm going to go ahead and fill this in as if the cold front is winning. Again, this happens at a low pressure system. Cold fronts are fast. The air at the front is moist. You have a cumulonimbus cloud at that front with some other clouds that will also result. Usually a smaller area would receive this front. We already talked about how it gets extreme weather like tornadoes, hurricanes, severe weather. And then again, if the cold front wins, then that area will be replaced with that cold weather. So the temperature will decrease, the pressure will increase, because remember that cold air is really contracted, and the humidity will be squeezed out of that air, and that humidity will decrease. We get very high wind speeds at the front, and they should remain high after that front passes through. So that is fronts in a nutshell. I'm actually going to back off this for just a sec, and I'm going to take a picture of it and let you see it all together. That is what you need to know. You need to know all of that stuff on that paper. And you also need to be able to identify these different fronts. So see that? Those are the different fronts: cold front, warm front, occluded front. You need to be able to draw them. You need to be able to identify them and identify all of their different characteristics. All right, I have a few review sheets that I'm going to give you. I'm going to give you a front and back review sheet, which I will do a Loom to walk you through how to do the review sheets and the lab that I'm going to give you next. So after you view this video right here and after you really know fronts, we're going to put it all together because this is it. And I'm going to give you a huge lab that will probably take you a few hours. So what will come next is a Loom video that will explain to you how to go through this lab with some helpful hints. All right. I hope you found this helpful, and I hope you were able to understand it. And I also hope you have a great day. Thanks, guys. Bye-bye.